In science, the study of the composition, reactions, and states of matter is known as chemistry, while the study of the way matter behaves in space is known as physics. Now, basically, we're going to address a concept in science that, when you think about it conceptually, is almost kind of a combination of the very basics of these two subjects, but really in reality deals with more of the composition and the operations of matter itself. And that is the laws of matter, or the different principles of how matter reacts when placed in different areas. These are known as the gas laws, or, of course, as I previously just stated, the laws of matter. Now, to understand this, there are really 4 or 5 main laws of gas and matter that are dealt with when trying to understand this subject. The first was created in the early 18th century by an English scientist by the name of Robert Boyle, who creatively named his theory Boyles Law. In this subject, he basically argued that if temperature is constant, then the amount of pressure and the amount of volume that a particular piece of matter has will go inversely, meaning that the more that you apply pressure or the force applied to a particular matter, the more the matter's space or its volume will expand or decrease depending on whether the amount of pressure, the amount of volume is increased or decreased, as they will operate inversely of each other. So, for example, if we look at a tire pump like this, the more that I apply pressure or force to the force inside of the tire pump, like this, eventually the volume of the force that I'm adding will expand, and over time, because volume expands inversely of pressure, it'll become harder for me to pump the pressure, and eventually I'm going to pump less in because it's going to be too difficult. The volume is acting against the pressure. Same thing is, if I pumped more slowly and not as much, it would still be much easier for me to pump in the pressure because there is a lower amount of volume inside the pump. Now, this is a very basic and overarching law, and one way that it transitioned into dealing with more basic and visual states of matter was by another French chemist by the name of Jacques Charles, who in the late 1700s and early 1800s proposed a theory known as Charles's Law, once again very creatively named, in which he basically stated that when pressure, that was what was Boyle's Law, when pressure is constant, or the amount of force that I am pumping into a particular piece of matter, that volume will either increase or decrease alongside an increase or decrease in temperature. So basically, if I have matter and it's at a constant pressure, there's a constant amount of force being pumped into that matter, basically the volume will increase if the temperature increases, and it'll decrease if the temperature decreases. So, for example, we take a bag of good old Lay's potato chips, and if I put this bag of potato chips where there's a constant pressure, no force is being pumped in or out of it, basically what will happen is that the volume, or the amount of force that fills up the bag, will increase if the temperature increases, and it'll decrease if the temperature decreases. This is why if you leave a bag of potato chips or anything like this out in the hot sun, over time you'll notice that it'll actually expand because of the fact that, according to Charles's Law, volume expands when temperature increases, and it contracts when temperature decreases. This is why, in general, if you notice, if you ever boil water, for example, the volume or the space of that water will increase as a result of Charles's Law and will decrease as the water cools. Although when it freezes, that's a different story that we'll get to another time. Now, a third law that was proposed when dealing with this concept was called Gaye-Lussac's Law. Another 2 sets of French chemists who determined the exact opposite of what Charles did, that basically the inverse of his theory also applies. And that was the fact that when volume, or the amount of space matter takes up, is constant, basically the pressure, or the amount of force being pumped into it or out of it, will increase or decrease depending upon an increase or decrease in temperature. So for example, if I leave a bag of Lay's potato chips outside, and let's say it has a constant space, it's already been filled up to the maximum amount of space that it can have, or it's been shrunk, the amount of volume has been shrunk to where it's basically taking up as little space as possible. If I leave it out in the hot sun, what will happen is the amount of pressure or the amount of force being applied to it will increase alongside an increase in the temperature, and it'll decrease alongside a decrease in the temperature. Now lastly, there was a formula that was created over the past century in which many scientists determined that all of these principles, Boyles Law, Charles's Law, and Gaye-Lussac's Law, can basically be combined into one giant equation which determines the volume, pressure, and temperature of a particular piece of matter over time in different conditions. So basically it goes to show you that science is all connected and all rooted in one concept. Now there is one more crucial law that, while it was actually derived and devised earlier than Boyle's Law, Charles' Law, and Gaye-Lussac's Law, it nonetheless applies in a different direction. And what that was Pascal's Law, created by the 17th century French polymath Blaise Pascal. He proposed that because of the way that volume and matter works, if let's say matter is constrained to a particular area, so for example, the matter is the force or the air that's being kept within this Lay's potato chip, the more that I would try to apply increased pressure or volume to the Lay's potato chip bag, it could not exceed or expand the amount that is possible within the bag. So for example, if I have the whole bag filled up and I try to apply more pressure or more force or more matter or more air into the bag, basically at some point it'll basically implode, it'll blow up, because of the fact that the matter cannot be contained. You can't add more matter to a space that already meets the capacity of that matter. This is why, if you notice, if you try and place more water into a container, the water will only move the different compartments.